Good morning, everyone. This is our next video, the intersection of three planes and the connection with solving systems of equations, which we've already seen a bit of in chapter 3. So let's revise a bit of chapter 3. I gave you a handout that looked something like this, where we take a 3x3 system and the colors show you how the quick way to solve the system goes. We start with that yellow grid of numbers, which corresponds to this, and then we move across to the green one, which corresponds to this, and then to the blue one, which corresponds to this. So I'll give you a few moments just to remind yourself what these numbers are here. You can fill them in on the handout. So pause the video for a second. Okay, you should have this. Then the system continues on the next row. If you remember the... Hey, wait a minute. Oh yeah. Yes. Then the system continues on the next row in a similar fashion, going across as follows. So I think that's pretty clear if you follow the color coding. So again, pause for a second, see if you can fill in the next row of the matrix. And this is what you should have. And then finally, we have to move down to this level. Again, it's very systematic. We start with this box, which is the blue one, and then we move across to the yellow one as follows. So pause the video again, see if you can fill that in. And here's what you should have. So the final row, minus 30, or rather 0, 0, minus 30, minus 30, is telling you minus 30z equals minus 30. So it's easy to find z as 1. And then by replacing that value in the other equations, such as 3y plus 5z equals 8, we can find y equals 1. And then replacing them in the first one, we can find x is 1. Hope you remember that, okay? And what we also saw in chapter 3 was the final row of the matrix tells you about the number of solutions. So here I've done examples of the final row and what those final rows tell you, but I've messed them all up basically. Have a think for a moment which one belongs, which of these sentences belongs to which final row. Maybe pause the video for a second. Okay, so it goes like this, doesn't it? So this is the one we just did. It gives one unique solution. This gives infinite solutions because any values for x, y, and z, when you multiply them by 0, will give you 0. There's no unique solution there. Whereas this one cannot give you an answer because you're effectively saying 0 times z equals 1, and that can't be done. So our first example in finding the intersection of three planes goes like this. But actually, we've just done that. We found the solution was 1, 1, 1. And if we look at that autograph, here's the first plane, here's the second plane, here's the third plane. We're going to investigate in the next video different ways these planes can be configured. You can see clearly they meet at one point, and the point was 1, 1, 1, which if I press OK, you should see it appear right there. That's the point of intersection. Okay. In the next video, we will consider other configurations of two planes and three planes.